Wait, your lens is dirty. You can just wipe it.
How
or
can you
something.
tell?
Just looking at it.
What? I can't even see anything. Wipe it with what?
I don't know.
Don't you need like a special cloth?
Didn't your camera come with a cloth?
What about this guy? Are you
Your,
sure?
your camera came
So
with
we
a
have white
cloth. And so that worked.
No, it didn't.
But yeah, I can see someone's fingerprint on it. That looks fine. But yeah, I can see someone's fingerprint on it.
Still doesn't look right.
No one has to.
Yeah, whatever.
Did you die?
Okay, don't touch. Okay, I decided we're just gonna do every single problem because you guys have to know all these things thoroughly.
So I'm never gonna.
So you're not doing homework today?
The next time you say that, you're out. And today I can stay at 6 o'clock. And then I can write your coach a note.
I practice right after school.
Doesn't matter, I'll write you a note. If you got detention, you got detention, sister. Wow. What's all this? You got it's so wet and so heavy. Yeah, what? Hey, where, can somebody steal my page here? Okay, where did we leave off yesterday?
I left here.
Number 8. I'm just going to call on you for the key steps. Okay, so since this problem, it is difficult or impossible to solve for y, we're going to use implicit differentiation. Whose turn is it? Takushi. First step. Oh yes, that's correct. Everybody got that? And that's the most important step when you do implicit differentiation. Now, I can see here that you can divide by 2 to make the number smaller. You want to do that?
Yes.
Okay. So you got 3x plus y plus xy prime plus y prime equals 0. Put all the y primes on one side. Throw everything else on the other. Factor out the y prime. This is all algebra. And then divide. Negative 3x minus y over x plus y. Now, the last several years on the AP exam, okay, you know, once you hit those 6 free response problems, you're going to know 4 of them already, like what the general topic. This is one of them. You got to do implicit differentiation. And what they typically do is they give you this equation and then they ask you for part A. Show that dy dx equals that. They actually tell you what the answer is. You just have to show this work in between. So. What? Yeah. No? Wait. Oh, she's here.
Oh, it's a she. Oh, it's a she. Wow, that was so short today.
So what's the question now?
You should go to
Okay, they're going to give you this. Part A. Show that dy dx equals this.
Wait, that's guaranteed one question.
Yeah.
Wow.
But that's just part A. So if this problem is worth 9 points, that's like 3 points.
Does that have to be every single step?
What?
Does that have to be every single step?
No, you got to show this is the key step right here. You got to have this, and then algebra, they know people can do some algebra in your head. Yes.
So we can just show that step and then stick to the bottom.
Yes, well, you playing with fire when you do that?
That's what
Yeah, but yes, you can, yes.
gives it the same.
Because when we grade it, this is how they do it. They go 2 points for this, and then 1 point for that. That's how it is. Okay. Now, you know why they do that? They tell you the derivative because they don't want you to screw it up for the next 2 parts. Because, what? I just said that. Okay, B. At what points on this graph is there a horizontal tangent? We did this. Okay, now this graph, you don't know what it is, but I'll tell you, it's like a tilted ellipse. That's what it is. Where on this graph is the tangent line gonna be horizontal like this? So there's like 2 points. Anyway, what is the slope of a horizontal line?
0.
0. And the derivative tells you the slope.
Tan equals 0.
So you set the derivative equal to 0. So if you write this down on your paper, here's the derivative. If you just make it equal to 0, ding, you get 1 point. That's 1 point because that shows understanding. Now, if a fraction is equal to 0, that means what? The top is 0 or the bottom is 0? The top is 0. And what am I going to do with this? We did this. Yeah, you solve for one of the variables, doesn't matter which one, and then plug it into the original equation because we want to find the points on the original graph. This is the original graph. So which variable is easier to solve for? You want to go y equals negative 3x?
Yeah.
Or would you rather go x equals negative y over 3? It doesn't matter. It doesn't matter if you like fractions or not. Then you take this and plug it into the original. So 3 times x squared plus 2xy plus y squared equals 24. You write that down, you show them that you plugged it in, you get another point, and then the last point is going to come from, can you solve this equation? So let's see, 3x squared minus 6x squared plus 9x squared equal 24. 6x squared equal 24. X squared equal 4. X equals plus or minus 2. You don't put plus or minus, you lose a point. Now you have to find coordinates now. They're asking what points on this graph. So we know the x coordinates are plus or minus 2. How do I figure out the y coordinate?
Plug it in.
Plug it back into the original?
Yes.
No, plug it right back. Oh, come on. Y equal negative 3x. The y coordinate is simply negative 3 times the x coordinate. Katoosh. Isn't that pretty easy? Okay, now part C. Well, once I showed you part B, part C is easy. Where do you have a vertical tangent? What's the slope of a vertical line? Undefined. So if this is the derivative, what would make this undefined? The denominator gotta be 0. So if you show that you're setting the denominator equal to 0, you got a point. Then you have to take that and plug it back into the original graph. So what? You want to go y equal negative x or x equal negative y?
Negative x.
Just pick one and go with it. Plug it in. 3x squared plus 2xy plus y squared equals 24. 3x squared minus 2x squared plus x squared equal 24. 2x squared equal 24. X squared equals 12. X equals plus or minus root 12. Okay, now, can I leave it root 12 or do I have to change it to root 3? You can leave it root 12. Remember I told you you don't have to simplify any arithmetic. Because if you try and simplify it and you do it wrong, you're going to get a point. We don't take off like fractions of points. It's either minus 1, 2, or 3. So just leave root 12. If you feel confident, then to root 3. Okay, so we know the x coordinates are plus or minus root 12. So how do I figure out the y coordinate? Where do I go back to?
Plug it in.
Go back to the original? Don't be... Y equals negative x. So you just multiply by negative 1. Katana! Katana! What's your answer? They want you to volunteer an answer, so make sure you box. They want you to present an answer somewhere on your paper. Okay, so that's how the typical implicit differentiation problem goes. And then, see, what happens is usually part A and B are doable, and then part C, they want to separate the sheep from the goats. That's what happens. So part C, they'll throw something in there to see if you know what you're doing. Okay, number 9. Number 9. Okay, so this is the position of a particle. 8p cubed plus 18p squared minus 16p plus 7. Find the initial velocity, find the velocity each time it's 0, we're decreasing, speed increasing, random, okay. So there's a whole bunch of questions. So what do we need to do? What's the first thing? Find the velocity, which is the derivative. So 4t cubed minus 24t squared plus 36t minus 16. Now, we need to make number lines for both the velocity and acceleration. So how do I factor this thing? Synthetic division. Anyway, the first thing you should note, you can take out a 4, right? Did you guys even notice that?
Yes.
Oh god. Okay, now remember, since we're AB, if you do synthetic division, what's going to happen? 1 works. In fact, I'll tell you the truth. I haven't seen synthetic division on the AP exam since the 70s or 80s. That's the last. No. Yeah, right around the mid 80s they had synthetic. I haven't seen it since. But you never know. So you just got to be ready. 1, 1, -5, -5, 4. So you're just playing with fire. You just assume it's not going to be out there. So if the remainder is 0, t minus the number in the box is a factor. What's the other factor? We look at these coefficients right there. T squared minus 5t plus 4. And then can that be factored some more? You bet your did be. T minus 1, t minus 4. But that's like t minus 1 squared. Okay, shall we make a number line? Woo! 1, 4, plus, minus, minus. How did I know it was plus, minus, minus? Because if you plug in a number bigger than 4, you get 4 times positive times positive, which is positive. But then since you have an odd power on that, it changes. But then since this one has an even power, it stays the same. Or if you don't know anything, just plug in like a number between 1 and 4 and plug in a number over here, like 0. Okay, now we need to make a number line for acceleration. So we need to take the derivative of velocity, which is, well, t squared. See, this is a polynomial. It should be very easy to take the derivative. I can factor out a 12. Oh, this is a good problem, I think. No, it is. Okay, but you know what? When I make my number line, I'm going to make it right underneath here. So 1 and 3. And how do I know it's going to be plus, minus, plus? Because I'm the teacher. Yeah, it's parabolas. Above, below, above. Okay, now, we can answer all the questions right now. What is the initial velocity? That means what is the velocity when time is 0? Here's your velocity equation. If I plug in 0 for t, what do you get? Negative 16. That's your initial velocity. Find the velocity of the particle each time the acceleration is 0. Okay, here's the acceleration equation. When will it be 0? What will make the acceleration 0? 1 or 3. So they want you to compute the velocity at each of these times. So what is the velocity at 1? What is the velocity at 3? How do I find that out? You take these numbers and you plug it into the velocity equation now. If you ask me, I think this one here, they're all equal, right? I think this one's the easiest. Can you see if you plug in 1 here, you get 0 already? And if you plug in 3, 3 minus 1 is 2, so that's 4. 4 times 4 times negative 1. Negative 16. Next question. When is the velocity decreasing? Okay, now look at C and D. There's a difference between the two now. When is the velocity decreasing? When is the speed increasing? You got to know the difference. Now, how do you determine whether a function is increasing or decreasing? What tells you whether a function is going uphill or downhill?
If the derivative is positive.
Yeah, it's derivative, right? If a function's derivative is positive, that means the function is increasing. If the function's derivative is negative, it's decreasing. So the velocity is simply a function, right? So when is the velocity decreasing? When its derivative is negative. And what's the derivative of velocity? Acceleration. And here's the number line for acceleration. Look at it. When is the acceleration negative? Between 1 and 3. That's your answer. You guys understand that? Okay, but when they ask you, when is the speed increasing, that's the same thing as asking, when is the particle speeding up? We talked about this yesterday. How do you determine whether the particle is speeding up both the velocity and acceleration have the same sign. So that's why it's good to line up the number lines like this. So when do the velocity and acceleration have the same sign? Between 1 and 3, and then from 4 to infinity. You see the difference between the two? They're going to ask you that, I guarantee you. That's why I put all of these in. Basically, I looked at the last 20 years and I just made this cheat sheet right here, or worksheet here. Write an integral that represents the net displacement of the particle from t equals 0 to t equals 5. Come on, that's right off the cheat sheet. How do you find net displacement? The integral from 0 to 5 of the velocity dt, that's it.
Oh,
The velocity.
I said dt.
Oh, you don't have to write out the function.
No.
Wait, let me look. No. And you know why? Because it's defined on your paper already. V of t is this. As long as it's defined on your paper, you can use it. F, write an integral without absolute value that represents the total distance traveled. Now, of course, the total distance traveled is the integral from 0 to 5 of the absolute value of the velocity dt. But they want you to write it without absolute value. Yeah, so that's why here's your number line for velocity, right? Look. This is your number line right here. The velocity is negative here, here, and there. So that means you got to split that up into separate integrals. So from 0 to 1, what? Let's go down here. So integral 0 to 1. The velocity is negative, so what? Negative v of t dt. If the inside is negative, you negate it. That's how you handle absolute value. Okay, what about from 1 to 4? It's negative. So what do? You negate it. Now some of you are noticing, Mr. Park, can't I just combine these two together into just this? Yes, you can, because that's one of the properties of integrals. And then from 4 to 5, the velocity is positive. So you leave it alone. There. That's how you handle absolute value. You have to know whether the inside is positive or negative. Yeah.
I should do that.
Yeah, I did.
Oh, yeah.
That's the second time you're not listening.
Yeah.
No, you're not.
Just lost.
Okay, number 10. Oh boy.
Get the homework.
I think that's good.
Again, I'm not going to congratulate you on things you're supposed to do. Like, Mr. Park, I invented this. Okay, congratulations.
You wouldn't say.
I invented money. Okay, this category, this is optimization. Now, optimization is usually going to show up on a multiple choice question. But you just never know. The last few years, it's multiple choice. Okay, you have an open top box with a square base, so it's like x and x. Now, usually they'll label it for you if you're lucky. And which means this, you don't know, so let's call it y. The volume is to be 4 cubic feet. Find the dimensions of the box that will require the least amount of material. So what are we trying to minimize in this problem? The surface area of the box. So when you do optimization, you have to write a function for the thing you're trying to optimize. In this case, the surface area. So what is the surface area of the box? You got a square on the bottom. And then you have 4 rectangles around the side. 4x, y. Now the problem with this is that you have 2 variables. We have to get rid of this variable so that we can take the derivative. That's why they tell you the volume is 4. So what's the volume of this box? X squared y equal 4. And what am I going to do with this equation? Yeah, you solve for one variable and plug it back into this equation so that you have just one variable. Y equals 4 over x squared. Take that and plug it in there. Did you guys do that?
Yep.
Or are you just copying now? So if you get x squared plus 16 over x, that is your function. See how it's a function of only one variable? Now you take the derivative. Right? Because to find maximums and minimums, okay, what's the procedure for finding maximums and minimums?
Find the derivative.
And make
Number
a number
line.
line. And then you write that sentence I told you. Okay, so A prime. Okay, I'm not going to do this. You guys are going to do this. Who's next in line? Yamane. A prime.
2x.
They don't get strikes.
we're looking at this now.
Oh.
You don't want to use product rule in this, right? Isn't it better to simplify it? Or is that what you're doing? Product rule.
What am I doing?
We're taking the derivative of this.
Oh, okay, sorry. X. What plus X?
Either you use the quotient rule, which I don't recommend, or you think of that as x to the negative 1, right?
Yes.
Okay, so that.
Wait, so put the 16 on the side. And then,
Okay.
and then,
Or maybe if I write it out for you here. Here you go.
derivative. Oh, x to the negative 2
And what sign goes there?
times. What sign?
Put the power in the front.
Oh, minus.
Okay, you're scaring me, Amano. The derivative of x to the nth power is nx to the n minus 1. Okay, now we need to make a number line. What's going on back there? Teruya, you will come back after school.
No.
Yes, you are. So that's it, strike 2, strike 3, you got. Okay, 2x minus 16. Most of you don't like to work with negative exponents. Write it as a fraction again. Make a least common denominator. So you're going to have 2x cubed minus 16. And look how beautiful I make it. Factor out 2. And you got that. That brings tears to my eyes. So on the number line, 0 and what makes that 0? 2. See, I'll make a nice cube root of a is 2. And how do I know it's going to be plus, minus, minus? Whatever, just plug. You guys are just copying off the board. You guys got to be able to do that. Plug in like 3, plug in 1. Actually, we really don't care what's there. You know why?
Because you can't have it.
Yeah, come on. How can the edge of a box be a negative number? Come on.
You can't really have it 0 either. So don't you just need
This better be good, Terry.
Wait, so can you just like set it equal to 0?
No, you.
And then do it after and guess and check.
You want to get maximum points or minimum points? Just do it the way I teach you. And no. I didn't grade the AP exam for 6 years. No, I don't really know anything. I don't even teach you this class for 26 years. What do I know? Nothing.
This answer comes out.
Yeah, I know the answer. How much is the answer worth? On a free response, 1 point for the answer. Then you need supporting evidence. That's what you need. And even if you guess the answer out of the blue, you're gonna get the 1 point for the answer. Like if you don't have any work and then you put down 2, you will get 1 point. You will. But you're not gonna get the other 8. That's the problem. Okay, now what do I need to write underneath this if I want to maximize my point? A is decreasing. A is increasing. You guys gotta get into the habit of doing this. You're probably only gonna do it once on the free response. So I don't think you need a legend. Okay, so x min is equal to 2. So if you want this to be a minimum surface area, x has to be 2. Now answer the question. Where's the question? Find the dimensions of the box. 2 by 2 by, what's y? Yeah, go back to this equation right there. 4 over 2 squared is 1. So your answer should be 2 by 2 by 1. This is called optimization.
Is just saying x equal 2 and y equal 1, is that enough? Or do you have to write it like?
Well, if it's multiple choice, then you just go pick out the answer. Once in a while, they have this on the free response. Like I told you, out of the 6 questions, we're gonna know 4 of them. The other 2, you just gotta be ready for anything. Just don't get 0. Because then if you get 0, that's the same as the people who don't know anything. They just sleep, right? You get the same score as them. Okay, number 11. What category is this? What is this? Related rates, okay? The length of the rectangle is increasing. So anything that changes, you have to label with a variable now. And the width is decreasing. So this and this are changing. You have to label it with variables. You cannot just go, oh, at the moment when the length is 4. You cannot just say, okay, that's 4. It's because only at that moment in time it's 4. So you label with variable. Okay, at this exact moment when the length is 4 and the width is 3, how fast is the diagonal changing? Okay, now if you look at your notes, there's a 3-step process for doing related rates. First step, you write the equation. Second, you take the derivative with respect to time. And then third, you just plug in the numbers. Okay, here's the diagonal. What do you want to call it? Okay, X, I heard X, D, whatever. Okay, now look at that picture. What equation can I write looking at that picture? Are you serious? Pythagorean theorem. X squared equals L squared plus W. You write that down and get 1 point. Then you take the derivative with respect to time. Okay, whose turn is it? Rossi Di Leon.
2x. Wait, x dot. No, yeah?
Mm-hmm.
Okay.
Or dx dt, right?
Yeah. X dot.
Remember, because we're taking the derivative with respect to time now, not with respect to x, with respect to time. Okay?
2L dot plus 2W.
There you go. And then you can divide everything by 2. Okay, and then now all you gotta do is plug in the numbers. It says, how fast is the diagonal changing? So we need to find x dot. So in order to compute x dot, we have to substitute things for all of that thing fast. Okay, what do I plug in for L? Okay, I'll answer 4. W, 3. L dot, 3. W dot, -2. How come I plug in -2? Because the width is decreasing. It's getting smaller, which means its derivative is negative. But Mr. Park, they never told me what x is. Yeah, but you can figure it out. If at the moment when this is 4 and this is 3, what is x? 5. That's a 3, 4, 5 triangle. So therefore, x dot is equal to, now if you wanna be a weakling, you can just do this on the AP exam. 4 times 3 plus 3 times -2 over 5. That is full credit. You don't have to simplify any arithmetic on the AP exams. Yeah.
Don't you have to put inches per second?
Units, yeah. Well, I'm talking about for the answer point. The
Oh, so
unit
you
is a
get
separate
You
point.
get a separate point just for
Yeah.
putting units?
Okay, yeah, but the rule is, if you don't have an answer and you only have units, you don't get nothing.
So if you put like, if you don't know anything, you put 0 inches per second, you'll still get a credit for units.
Okay, so if you're smart, yeah, you put a number there. But by the time we take the
7 inches per
AP
second.
exam, you're gonna know how to do this.
You said there's
Why?
two we don't know.
Why? What?
You said there's 2 we don't know.
But you're gonna know how to do it.
So you're talking
Right now, you're in the dark. That's because you just came from spring break.
black.
6 weeks from now, I expect everybody to be machines. Okay, what are the units? Some of you still screw up on the units. Look, x dot means dx dt. If you don't know what units to put, just look at that and that. If you have to measure x, if I have to measure that, what units is that? Is that square inches, or cubic inches? If I have to measure that, that's inches. And what about time? Just look for, it's either seconds, minutes, or hours, right? What is it?
Inches.
We're doing time.
Oh.
Light
Second.
year.
How about like you read the words in the problem? You guys cannot be that dumb. You cannot be that dumb. Okay, how fast is the area of the rectangle changing? Okay, here we go. Write an equation. What's the equation of the area of a rectangle? I'm not going to insult your intelligence. Second step, take the derivative with respect to time. Nemoto. Mhm. Very good, you use the product rule. If you don't use the product rule, pretty much you're out of the problem already. Okay, and then all you gotta do is plug in the numbers. So if you wanna find A dot, you just plug in numbers for each of these things, but they were all given, right? I think this was 4, this was 3, this was 3, that was -2. And you can just leave it. Because if you don't trust yourself to go 9 minus 8 is 1.
I got 17.
What?
I got 17 the first time.
That's because you didn't plug in negative 2?
I know.
It's decreasing. Okay, and what are the units? This is like dA dt. This is area over time. How do you measure area? In square units, right? So it's square inches, and the time is in seconds, right, in this problem. Some of you, no, I'm serious, you guys have problems with units. Okay, C. How fast is the angle formed by the diagonal and the length changing? This angle right there. Okay, let's look at this picture. Okay, now, what equation can you write? You can write cosine theta equal adjacent over hypotenuse. You can write sine theta is
Wait, we
opposite.
use tangent.
Or you can use tan theta equal that over that. It really doesn't matter because they're all related. I like tan. Tangent theta is equal to opposite over adjacent. And since we're trying to find theta dot, I'm going to solve for theta. Theta equal
Tan inverse.
tan inverse W over L. Now you take the derivative with respect to time. Around the door. Okay, I'll do the left side. Theta dot.
1 plus L W.
Tan inverse box.
Oh, W over L
Okay.
times over square root.
Wait, I'm not going to be there watching it. Times.
L W dot minus W times L dot over L squared.
Very good. That's the quotient rule, right? Because when you multiply by the derivative of box, you got to use quotient rule. And then you plug in the numbers. You guys can plug in those numbers, right? And then what are the units going to be? This is like d theta dt. So angle over time. All angles are measured in radians, and this problem, everything is seconds. Yeah? Radians per second. Yeah.
If you did like sine theta, if you did sine theta,
Then it will be W over X.
can you just find the derivative without sine inversing both sides?
Yeah. So, yeah, there's so many things you can do as long as you do it correctly. So if you went sine theta equal W over X, then you would go, the derivative of sine box is cosine box times the derivative of box equals, and then you use the quotient rule, low d high minus high d low, all over denominator squared d low.
And cosine theta is just L.
So at that moment in time, this was 4, 3, and 5. So at that moment in time, cosine theta would be 4/5. Yeah, it all comes up. Just like a high fiber diet, this all comes up. Or maybe it doesn't. Oh, this is a good problem. Okay, this problem,
Wasn't on the homework.
every year students get confused between the average rate of change, average value, and the mean value theorem. Every year they get confused. And this is probably no different this year, yeah? So we have to clear it up. A, find the average rate of change of f of x from x equal 1 to x equal 9. Now what the heck is the average rate of change? It's in the cheat sheet. It's simply the slope of the line connecting 2 points. Average rate of change, you don't need any calculus at all. It's simply this. This is the average rate of change. It's simply the slope of the line. Isn't that the slope formula right there? So, when x equals 1 to x equals 9, this is A, this is B. Here, come right through. A and B. And here's the function. So what's f of 1 and f of 9 then? What the heck? Let's just plug it into the formula. F of 9 minus f of 1 all over 9 minus 1. That's how you find the average rate of change. So what is f of 9? Plug in 9 there.
3.
3 minus square root of 1. All over 9 minus 1, 8. Just leave it. Right? You don't need to simplify that because you're scared to go 3 minus 1 is 2. And reduce it to 1/4. Chicken. B, find the average value. Okay, out of all of these, the one that's going to appear the most often on the test is average value. Okay, when you see the word average, then it means average value. Okay, so how do you find average value from 1 to 9? What's the formula for average value? 1 over b minus a, integral from a to b of f of x dx. And I think we know how to compute that integral, right? And then part C, find the value of C that satisfies the, you guys even remember what the mean value theorem is? I'm afraid to even ask if you guys even remember the intermediate value theorem. Okay, let's just worry about the mean value theorem. This is what the mean value theorem says. I'll explain it. If you have a continuous and differentiable function, that means it has to be smoothly continuous from A to B, then there's at least one place between A and B such that f prime of C is equal to f of B minus f of A all over B minus A. In other words, okay, f prime means the slope of the tangent line. There's going to be at least one time in between here where the slope of the tangent line will be the same as the slope of the line connecting the two endpoints. That's what the intermediate value theorem is saying. There's at least one place where the instantaneous rate equals the average rate. But you have to be able to find that value of C on the multiple choice. Well, all you gotta do is use the formula. Oh, okay, f prime. This is your function. F prime means take the derivative. What's the derivative of root x? You're supposed to memorize this.
1/2 root x.
1/2 root x. And then you plug in C. You don't really have to plug in C if you don't want to. And that's equal to f of B minus f of A over B minus A. But yeah, we figured that out in this problem here, right? 1/4. And then all you gotta do is solve for C. So cross multiply. So you get 2 root C equals 4. Divide by 2. Square both sides. C is 4. So see, this was 1 and this was 9. So when x is 4 right there, the slope of the tangent line is equal to the slope of the line connected to two endpoints. That's the mean value theorem.
It should be 9.
What?
9.
It is 9.
Oh, wait a second. I think I'm 4.
Okay.
Can you do B? Because I tried doing B, but then I came up with something.
There's the integral here.
Yeah, because this says it's 13/6.
Okay, 1a. Okay, now the antiderivative of that is x to the 3/2 with a 2/3 in the front, from 1 to 9. Factor the. We don't, when to compute an integral, we don't even know to take the antiderivative.
I would need too much derivatives, that's why. Oh, I thought they were sure.
I have some of my son's medication in my backpack. I can force feed you some.
Wait, me?
Force the into you and you
Okay,
You
what
too.
time is it? What time is it? Okay, look. Okay, I think we'll be able to finish by tomorrow, thank goodness, because we have. Okay, here we go.
Good math.
Let's try and finish 13 right now. No, that's gonna take too long. We only got 5 minutes. Let's pick one where we can finish it. Because 13 is gonna take at least 10 minutes. 14, 15, let's do 16. 16 and we're done then. And we'll do the rest tomorrow. This is the rate at which water is flowing out of a pipe. How many times have I given you this problem? Okay, so if they give you a rate, what do you have to do to figure out how much was done? You do an integral, okay? So how many gallons flowed from the pipe during the first 3 minutes? You do an integral. So integral from 0 to 3 of this thing dt. And again, remember, if they give you a rate, what are the units of rate? In this case, it's what? Gallons per minute. This is gallons per minute. And then you multiply it by the infinitesimal amount of time, which is minutes. You cancel out, you get gallons. Right? Which is how much was done, how many gallons flowed out of the pipe. Okay, now, the only kinds of integrals you're expected to do on the AP exam, it's either on the list or U substitution. If anybody does tabular, I will come and choke you. There's no tabular. Some of you want to do tabular for some reason. Okay, so how do I do this integral? U substitution. U equals dq plus 9. Usually the thing in the box, right? du equals, what's the derivative of this? 3t squared dt. It's actually du over dt, right? But we put the dt on this side. And then we substitute back in. So what is that? That's radical u what is t squared dt here? What is t squared dt equal to? Du, bring the 3 on this side, over 3, but we throw the constant on the outside. And this is something some of you still not knowing. If you make a u substitution, the limits need to be changed. These are the limits for t. It's from t equals 0 to t equals 3. So if you put 0 and 3 there, a point will come off. What are the new limits of integration? You plug in 0 here, you get 9. If I plug in 3 there, you get 36. You have to change the limits. And then, do we know how to compute this? I hope so. We just did it in the last problem. This is like u to the half. You make the power 1 bigger, put the reciprocal in the front. 9 to 36. Factor out the constant. And so that's 2/9 times, what's 36 to the 3 halves? Now, Mr. Park, can I leave 36 to the 3 halves? Or do I have to simplify it to 216? I think you can leave it. But I'm not going to take any chances. 216. Because I don't know what they consider arithmetic. I know addition, subtraction, multiplying, and dividing. But when you raise to a power, I'm not sure if you can leave it. Minus, what is 9 to the 3 halves? 9 to the 3 halves. How do you compute 9 to the 3 halves? You go with the half power first and then you cube it.
27.
Okay, that you can leave. I know that. But the power, I'm not sure. So I would not take any chances. Yeah.
But then if it was 36 to the 3 halves, you could just write 6 times 6 times 6 and then that's it.
Yeah, 6 times 6 times 6. Yeah.
Well, I don't think statistics are that hard. It's like, same thing. Probably.
Okay, now yes, I am going to do the rest of them on the board tomorrow. But it would be nice if you try and do it by looking at the notes. No, because when you study the notes, you gotta know where it is on the sheet, right? Some of you, I bet, you just put the notes in your folder. It's never been touched.
So much for nature.
Why am I looking at Walker Hero? That's why I said, why am I looking at you? I don't know. Why I'm looking. Yeah, the bell's gonna ring in a minute. Let's go already. It is raining hard.
Thank you, Mr. Barr. Lunch was very good.
It was.
Is the next review thing online?
The next one.
Yeah, the next homework.
Oh no.
This
No.
is it.
The rest of the homeworks are gonna be, I give them to you slowly.
Oh, so I cannot do ahead of them.
Yeah. Cause,
Okay.
yeah.
What's that?
No homework forever.
So can you